I'm Elizabeth with Logic Walk, and in this lesson, we're going to explore what happens when the cursor reaches the very last available space in the display matrix, yet there are still more characters to print. Let's begin by using the Logic Walk simulator to see the display in action. In this program, the display prints letters A through P repeatedly from the alphabet. I'll let the program run until we reach the last two available spaces in the display matrix so we can take a closer look at what happens to the cursor. This process takes a while, so I'm going to speed it up for you. At time 584, the display just finished printing capital O in position 3811. The memory cell shows a data size of 16, and memory cell 27 has a value of 1, meaning the display is ready to print. The display indicates that the number of characters printed so far is 15, and the cursor is at position 3911, the very last available space in the bottom right corner of the display matrix. At time 585, the display prints capital P at position 3911, which is the final spot in the matrix. Memory cells 26 and 27 remain unchanged, and the number printed increases to 16, and the cursor now moves to 011. This means the cursor goes back to the beginning of the last row at position 011, while the display shifts all existing lines up by 1. Let's rewind and see this change. At time 584, the first row of the display started with the letter A. At time 585, the first row now starts with I. The previous first row has disappeared as the rows shifted upward, making room for more characters on the bottom line. Now let's look at a more generalized scenario of what happens when the cursor reaches the last available space. Imagine that at some arbitrary time t, memory cell 26 holds a value n, representing the total number of characters the display should print. Memory cell 27 contains a 1, indicating that the display is ready to print. The number printed so far is p. Memory cell 10 plus p, which represents the buffer cells, will hold some value, which we will call val. This value represents the next character to be printed. The cursor is at position 3911, the very last cell in the display matrix. All other characters in the display are located in various positions, which we'll refer to as CX, CY. Now, if P is less than N, meaning there are still more characters to print, and CY is greater than 0, then at the next time step, T plus 1, the following occurs. The number printed P increases by 1. Memory cell 26 and 27 remain the same. Memory cell 10 plus P still holds val. The cursor resets to the beginning of the last row, moving to position 011, and simultaneously, each character in the display shifts upward by 1 row. Each character at position CXCY moves to CXCY minus 1. As a result, a new empty row, which we can call X11, is created at the bottom of the display matrix. For example, when the last row reaches capacity, the character in position 3811 shifts up to 3810, clearing the last row to accept new characters. That wraps up chapter 2. In our next chapter, we'll dive deeper into another key I/O device, the keyboard.